Hi, in this video, I will be showing you problem number 53 of chapter 14, section 3. Find all the second partial derivatives of f of xy, which is equal to x to the power of 4y minus 2x cube y square. So what we are going to get is the second partial derivatives. So second partial derivatives are f x x, f y y, f x y, and f y x. These are the second partial derivatives. It can also be called mixed partial derivatives. Now, the second partial derivatives are derivatives of the first derivatives. Second partial derivatives are derivatives of the first partial derivatives. So first we are going to compute the first partial derivatives, which are f sub x and f sub y. First partial derivatives, f sub x and f sub y, fx. For that you are going to keep y as constant. F of xy is x to the power 4y minus 2x cube y square. In order to do fx, f sub x, which is the first partial derivative with respect to x, keep y as a constant and then differentiate with respect to x. So this would mean 4x cube y minus 6x square y square. So let's call it 1, the first partial derivative. Then partial derivative with respect to y, again first partial derivative, but with respect to y. We have to keep x as constant in this case. So you get x to the power 4 minus 4x cube y, because you are differentiating with respect to y, that will give us 2y. So it will become 4x cube y. We call it 2. Then differentiate fx, namely 1, with respect to x to get f sub xx. So you are going to differentiate fx one more time with respect to x by keeping y as a constant. So it is 12x square y minus 12x y square. We'll call it 3. Now differentiate fx partially with respect to y. That will give us fx y, f sub xy. You are going to keep x as a constant. So you are going to take this step and differentiate with respect to y. So it is 4x cube minus 6x squared times 2y. That will give us 12x square y. So this is the second partial derivative on x and y. Then now we are going to take fy and differentiate that with respect to x. Differentiate fy partially with respect to x. So this will be fyx. So you are taking this step 2 and then differentiating with respect to x. So you are going to treat y as a constant again. So it will be 4x cube minus 12x square y. So we got fx, we got fy, first partial derivatives. And then in the second partial derivatives, we got fxx, we got fxy, and we got fyx, and we have to determine fyy also. So differentiate fy partially with respect to y by keeping x as a constant. So we take this 2 and then differentiate with respect to y. So that will be negative 4x cube. We'll call it 6. So thus we got fxx, fxy, fyx, and then fyy, all the second partial derivatives. So in the next video, I'll be showing you a result on Clairaut's theorem. We can prove that Clairaut's theorem holds good for a function, which is about, again, second partial derivatives. Hope this video helps.